Myself, Dr. Simmi Jain, and today we'll be talking about a very interesting topic, that is food additives. Food additive is a substance or a mixture of substance apart from the basic food substance which is present in a food as a result of packaging, processing, storage or production, and it does not include chance contamination. In order to enhance or look at a broader definition of what a food additive is, it is any substance which is not normally consumed as a food in itself, and it is normally not a characteristic ingredient of a food. Whether or not it has nutritive value, the intentional addition of which to a food for a technological purpose in the manufacture, processing, preparation, treatment, packaging, storage of such food results or may be reasonably expected to result in it or its byproducts being directly or indirectly a component of such foods. Here, let us understand what makes a food additive different from an adulteration. Food adulteration is also the addition of food substances which is done intentionally, but the addition is purely for the basis of increasing the quantity and thereby the profit margin, the addition of inferior substances, or taking out very vital elements from the food, or simply just adding cheaper substances to increase the quantity of the food substances. Food additives have become a vital ingredient in all your processed and packaged food, without which probably none of the packaged foods would have been possible. During the processing, a food undergoes a lot of stress in terms of extreme heat, the pH changes, the vacuum pressure conditions that are being put to the food, and thereby the vital elements in the food, be it the vitamins, minerals or the flavor or the coloring agents, tend to be lost, and thus such foods would not be acceptable to the consumers. To bring the food back to its original form to a larger extent, these additives helps us. So, in the processing of invariably all kinds of processed products, these additives are added in order to improve the nutritional quality, the substances which would have been lost, mostly the vitamins and minerals. They also are added to improve the safety or quality of the food, the addition of antimicrobial agents, anti-browning agents, and so on. They help in processing and preparation, such as the emulsifiers that are being added into our food substances, and they help to enhance the sensory characteristics by the way of adding coloring agents, flavoring agents, texturizing agents, and so on. And by the additions of all such variety of additives, they help us to maintain the palatability and wholesomeness of the food. Of the various classes of the food additives, today we will be talking about a major class of an additive, which is the preservatives. We all understand that food preservation is a process of treating and handling the food to stop or greatly slow down the spoilage, which is largely done by microorganisms. Some of the common methods which have been used in order to reduce the microbial load anciently were drying, such as sun drying or solar drying, and these days spray drying, freeze drying. Other methods like freezing, vacuum packing, canning, preservations using salts and syrups have been utilized. The only idea was to remove the air, which includes the oxygen, the moisture and the microorganisms, which will help to preserve the food for a longer period of time. Amongst the earliest preservatives that were used were salts and sugars, which provides an environment of high osmotic pressure, which denies the bacteria the aqueous surrounding they needed to live and reproduce. Jams and jellies and all the dry products which were manufactured are such examples of use of drying methods and use of salts and sugar. Looking at the classes of the food additives, there is class 1. These include those kinds of preservatives which generally do not require, which is not restricted by the law unless it is being provided in the rules. Examples of such additives includes salt, sugar, dextrose, spices, vinegar. Class 2 preservatives are basically those which are restricted in use and are provided by the law, that is benzoic acid, sulfurous acids, nitrites, nitrates and so on. The preservatives are further classified into 3 categories: the antimicrobial agents, the antioxidants and anti-browning agents. The antimicrobial agents basically play a major role in extending the shelf life of numerous foods. Examples of antimicrobial agents include sulfites, nitrites and nitrates, benzoates and its salts. Substances which prevent the lipid or vitamin oxidation in a food are termed as antioxidants. And the examples which are utilized as antioxidants are natural antioxidants like vitamin C and E, synthetic chemicals like BHA, BHT, propyl gallate and TBHQ. The third major class of food preservative is the anti-browning agent. The cut fruits and vegetables are the major class of foods which gets brown because of the action of enzymes, and thus sensory-wise makes it unappealing for the consumption of such foods. Anti-browning agents help in preventing the enzymatic and non-enzymatic browning of the foods. Vitamin C, citric acid are some of the most common additives which are used as anti-browning agents. We'll be now talking about the antimicrobial agents. Antimicrobial agents represent those antimicrobial agents which are in the category of E200 to 290. They prevent the biological deterioration and thus are termed as antimicrobial agent. They preserve the food by preventing the growth of microorganisms and thus the subsequent spoilage of the food substances. Some of the common antimicrobial agents which are used in food process are the sorbic acid and its salts, benzoic acid and its salts, sulfur compounds, phenolic compounds, nitrites and its salts and so on. Before we move on to what are the various kinds of antimicrobial agents, let us understand which microbial agent can be utilized in which kind of a food. The very first thing that we need to understand is the antimicrobial spectrum of the compound which will be used to be added into the food substances, the chemical and the physical property of the antimicrobial agent and the food to look into the compatibility of both of these put together, the conditions of the storage of the food so that the antimicrobial agent is able to sustain those stressful conditions, and fourth, that the food must be of the highest microbiological quality initially, and that is the reason why sanitation of a food or the hygienic quality of the food is utmost important to start with the use of antimicrobial agent. And finally, the antimicrobial agent should be toxicologically safe and the regulatory status of the selected compounds must be known to us. As I have told, sanitation is the utmost thing that we need to understand to start with any antimicrobial agent. An antimicrobial is never a substitute for a good sanitation in a food processing plant. If a number of microorganisms contaminating a food product is high, significantly higher quantities of an antimicrobial would be needed. The toxicological effect of the antimicrobial agent should be understood. Those agents should be non-allergic, should be safe for human consumption. They should be metabolized and excreted by our body. They should not result in the built-up of residues, and very important that they should not bind with or destroy important nutrients in our food products. They should be economic in use, or otherwise they should have the ability to pay for itself based on the reducing spoilage. The activity validation methods for most of the antimicrobial activities have not been understood, but further researchers will definitely help us to widen our spectrum of the use of antimicrobial agents in the coming days. The labeling of an antimicrobial substances requires that if we are using a very highly purified antimicrobial agent, it should be approved as a food additive, and also it should be listed using a chemical name on the food which it is being utilized on, which means that this method brings in a lot of expenses and time consuming toxicological testing. The sensory effect on the foods of these antimicrobial agents should be understood. These antimicrobials must be used at high concentrations to achieve the activity against the target microorganisms. Compounds that negatively affect the flavor and odor or contribute inappropriate flavors or odors would be unacceptable. At the same time, it would also be unacceptable for a food antimicrobial to mask the spoilage. The last thing that we need to consider for an antimicrobial to be utilized is the resistance development. An antimicrobial should not be selected solely according to its ability to control a predominant microorganism present in the food. Because of such specificity, selecting antimicrobials that control some genera but not the others may result in selecting for or creating favorable conditions for the growth of other organisms. Microorganisms exposed to stress may become more resistant and may have enhanced survival to subsequent stresses. Some of the natural antimicrobial agents that are being utilized in our food are those coming from the plants, the essential oils, which are taken from the oregano or the clove essential oils, mustard or the horseradish essential oils, which are respectively inhibiting against the gram-positive and the gram-negative bacteria. Enzymes such as lysozymes, which is a lytic enzyme which degrades the cell membranes of the gram-positive bacteria, and also the activity improves with chelating agents such as EDTA utilized along with these antimicrobial agents. Bacteriocins like nisin and netamycins, naturally occurring polymers like the chitosins, and organic acids like sorbic acid, propionic acid and citric acid. Dimethyl dicarbonate is a substance which is colorless liquid and slightly soluble in water. The primary target organisms for dimethyl dicarbonates are the yeast, including the Saccharomyces. It is also bactericidal at concentrations of 30 to 400 micrograms per milliliter. It is widely used in preserving wine, teas, carbonated and non-carbonated non-juice beverages such as sports drinks, and carbonated and non-carbonated fruit flavored or juice beverages. Nitrites and nitrates, which are widely used in curing meats along with the salt, sugar, spices and ascorbates. Apart from being acting as antimicrobial agent, it also helps in developing the color, flavor production, texture improvement and helps retard rancidity. In the meat, it gets converted into nitric acid and reacts with myoglobin to form heat-stable pigments. They help in inhibiting the growth and toxin production of Clostridium botulinum in cured meats. It is more inhibitory under conditions which are anaerobic at acidic pH with addition of chelating agents like EDTA and polyphosphates. The prolonged ingestion of sodium nitrite or sodium nitrate has been shown to cause methemoglobinemia, that is excessive production of abnormal hemoglobin, especially in infants. They also combine with secondary and tertiary amines to form N-nitroso derivatives, which have been shown to produce cancers in a wide range of laboratory animals. The lethal doses of nitrites in humans is 32 milligrams per kg body weight, but their addition is however very limited, as in high doses it can have risk on human health and environment. The benzoic acid and benzoates, they are found naturally in a lot of fruits like apples, cinnamon, cloves, cranberry, plums and other berries. Benzoic acid is a colorless needle and is much less soluble and is preferred less, whereas sodium benzoate is white granular crystalline powder and is stable and soluble in water. On the other hand, sodium benzoate is widely used for preserving fruit products like juices, preserves, soft drinks and pickled vegetables. They help in controlling yeast and molds and act synergistically with sorbic acid and sulfur dioxide. Its effectiveness increases when the pH is lowered below 4.5. Sodium benzoate has been used in a number of food substances in carbonated and still beverages, olives, pickles, soy sauce, jams, preserves, fruit salads and so on. The reason for low toxicity of the benzoate is that the humans and animals have effective detoxification mechanism for benzoates. Benzoates can trigger allergies such as skin rashes and asthma, as well as believed to be causing brain damage. The consumption of sodium benzoate may also cause hyperactivity. The benzoates have low order of toxicity in animals and humans, and no carcinogenic effect has been observed when rats were given a low level of sodium benzoate. It is used in beverages that also contain ascorbic acid. It reacts together to form small amounts of benzene, a chemical which causes leukemia and other cancers, though the amount of benzene that is formed is very small. Yet another category of the antimicrobial agents are acetic acid and acetate salts. These are the major components of vinegar, which is 4% acetic acid, and its salts, which is widely used in the foods as acidulants and antimicrobial agents. It is more effective against yeast and bacteria than against the molds and used widely in pickling the vegetables. Acetates of sodium, potassium, calcium are used in breads and bakery to prevent the ropiness and the mold growth, which is most commonly found in bread and baked products. It increases the shelf life of poultry and is also used as an effective antimicrobial dip for beef and lamb. Its activity increases with decrease in pH. Some of the common food substances are the baked products, cheeses, condiments, spices, dairy analogues, fats and oils, gravies and sauces. Propionic acid and propionates. These are primarily used against molds and some bacteria. Its activity increases when the pH is lowered and is extensively being used in bakery to inhibit molds and in some cheeses. Sorbic acid and sorbates, they are effective inhibitors of fungi, including those that produces mycotoxins and certain bacteria. The effectiveness of the compound is found to be greatest as the pH decreases below 6.5. Various ways in which sorbic acid and sorbates can be used is directly. They can be dusted in the form of a powder. They can be sprayed onto the food substances, dipped into sorbic solutions to prepare certain concentrations as required, and also as packaging material. They are widely used in cheese, dried fruits, yogurts, pet foods, dried meat, and a variety of baked products. Sorbic acid and potassium sorbate has been a common primary preservative in food preservation due to its good antimicrobial activity. But unfortunately, sodium sorbate and calcium sorbate, which were initially utilized, are now not approved as a food additive in EU since January 2018, as it has been found to be carcinogen, whereas in other countries they are still permitted, example as in the US. The sulfites, used as sulfur dioxide or its various salts, has a long history of use as a food preservative. It is used extensively as antimicrobial agent and also to prevent enzymatic and non-enzymatic decoloration in preserved fruits. The most effective range of sulfite is 4. The sulfurous acid inhibits yeast, molds, bacteria. However, yeast and molds are generally less sensitive to sulfur dioxide than bacteria. They are widely used to treat fruits and vegetables before and after the dehydration, to extend the storage life of fresh grapes, and in making fruit juices, wines, sauces, and acid pickles. It is used in gaseous form as sulfur dioxide, sulfite, sodium and potassium bisulfite, and metabisulfite forms. It has other functions as well in the protection against oxidative, enzymatic and non-enzymatic browning reactions, and inhibition of chemically induced color losses. Because sulfur dioxide is volatile and is easily lost in the atmosphere, the residual levels are much lower than the amounts which are actually applied onto the foods during the harvesting. The US FDA considers sulfur dioxide as safe sulfite salts as GRAS, generally recognized as safe. However, sulfites should not be used in meats, which are a good source of thymine, as it leads to cleavage of the thymine and makes it unavailable. In human beings, fatal poisoning is generally not possible because sulfur dioxide induces vomiting. But the toxic effect of this can be variable, varies from person to person, with a tolerant limit of 50 milligrams per kg body weight, whereas others may have headache, nausea or diarrhea. The parabenes are the alkyne esters of p-hydroxybenzoic acid. The alkyl groups can be one of the following as the methyl, ethyl, propyl, butyl or the heptyl. These are colorless, tasteless and odorless. These are also non-volatile and non-hygroscopic in nature, and their solubility depends on the nature of the alkyl group and the length of the alkyl chain. They are most effective in acidic and alkaline pH, a range of 3 to 8 pH. They are generally more active against molds and yeast than against bacteria. FDA considers methyl and propyl parabenes as generally recognized as safe with a total addition limit of 0.1%, and this allows single use or multiple parabenes to be added to the food as food packaging or otherwise an antimicrobial substance to prevent the spoilage. They have found to be low toxicity as they are rapidly hydrolyzed, they are conjugated in the body and excreted in the urine, and that is the reason why probably they have also been found to be non-carcinogen in animal studies. The phosphates have been extensively being used in food processing and preservation. Apart from these being antimicrobial and preservatives, they also help in stabilization of the pH, the acidification and alkalization, sequestering agents, dispersion, emulsification, nutrient supplementation and anti-caking agents. The phosphate derivatives also have antimicrobial activity in food products. Thank you.